Here we are for acceleration questions in problem set 1. Taking a look at problem number 4, calculation number 4. It says a world-class sprinter can burst out of the blocks to essentially a top speed of about 11.5 meters per second in the first 15 meters of the race. What is the average acceleration of the sprinter, and how long does it take her to reach that speed? Now, they already gave us this 15 meters. That's distance or displacement. So when they ask how long, they're probably not wanting distance. They're probably wanting a time then, right? Because we already know the distance. So we're trying to solve for time there. We know that this 15, we know that's the displacement. We know here that she's going to reach her top speed there at the end of that 15 meters. So this is going to be like the final velocity. And we're starting from rest, right? And so we know that V naught, she's coming out of the blocks, the starting blocks here at rest in 0 meters per second. And so those are the values that we know already. 1, 2, 3 values that we know, trying to solve for that time. And we're also trying to find the average acceleration, trying to find the acceleration. Okay. Why do we have the word average here? Because it's possible and quite likely that as the sprinter is getting started, that she's perhaps not going with one constant acceleration the whole time, and her acceleration is changing as we go. What average means in physics is if you had one constant value that would give you the same end result. So we're just going to assume it's one constant acceleration. That's what we're solving for when you find an average. So moving onward. So do I want to solve for time first or acceleration first? Again, acceleration pops up in all of our kinematics formulas pretty much. So I like to solve for that first when I have the option. Do I have the option? I've got enough information here. I've got displacement, initial velocity, final velocity, and acceleration. I can put together a calculation of those 4 variables. I want the formula that doesn't have time in it because I don't know that one yet. So the one doesn't have time. Again, that would be this one. V final squared is V initial squared plus 2a delta x. That's final velocity squared is initial velocity squared plus 2 times the acceleration times the displacement. Taking a look at this, we're trying to solve for acceleration. So I'm going to rearrange, subtract vf squared minus v naught squared divided by 2 times the displacement. That would give me the acceleration when I rearrange, right? Subtract this over and then divide both sides by 2 times delta x. All right, substituting in my values. Final velocity 11.5 meters per second squared minus initial velocity 0 squared divided by 2 times my displacement of 15 meters. So not going to be doing that one in my head. 11.5 squared divided by 30. That's what the 2 times 15 is. And I get a value of 4.4083 repeating. So I'm just going to round that to 4.41. And the units then, again, I make sure that these guys are in, I should have done this before I started, meters per second and meters, right? And so I am going to have answers here for acceleration in meters per second each second. So meters per second squared. There's my acceleration. Okay. All right. Now they'd also like to know how long it takes her to get to that speed. So now we're trying to find the time. Well, now I have initial velocity, I have final velocity, I have displacement and acceleration. I've got 4 variables trying to find the 5th. You say, I actually have my choice of a couple formulas. I could use V is AT plus V naught, because I know the initial and final velocities were given, and the acceleration I just calculated, I could solve for that time. Or I could use the other equation of delta x, with displacement and time, right? Because we're trying to find time, the other with time, which looks like this. Displacement is initial velocity times time plus 1/2 AT squared. And the displacement, I know is 15 meters. I know the starting velocity, it was 0, so this whole term is going to drop out. And I have 1/2 the acceleration I just solved for. I can plug in there, substitute that in there, and I can solve for that time. Do you have a preference for which one we use? I'm going to go ahead and use this one just because. Either one would be fine. Okay, either one would be fine. I could solve for the time with either one. You think I'm going to solve it both ways? You know what? I think I'll solve it one way, and I'll ask you to make sure you try solving it. If you haven't done it yet, try solving it the other way. Okay, let's try this one. Hey, my displacement. Oh, whoa. Yeah. I'm going to rearrange this to try to solve for A. And you notice that because we're starting from rest, right? Starting with an initial velocity of 0, that means this V naught is 0. So this whole term is going to cancel out. So I can just jump right to, I'll just jump right to my displacement of 15. Am I really going to do that? No, I'm going to rearrange. I'm going to rearrange. So I'm going to say, so this term's gone. So now I can just go ahead and multiply through by trying to get that time by itself. Multiply through by 2, divide by A. So I'll have 2 delta x over A. And that would equal t squared, right? So I'll do a radical there. All right, and that's how I'm going to get my time. Substitute in the values now. 2 times the displacement of 15 meters, divided by an acceleration I got there. And I recognize that this is a number that I rounded, and so that's going to introduce some error to this calculation. Not much. Okay, I can plug in my values in my calculator. 2 times 15 divided by 4.41. It probably would have been better if I just kept that calculation in my calculator, that value with all the extra digits, and fed that into the next calculation here. Otherwise, like error is going to propagate, get worse and worse each step as I keep rounding and rounding and rounding. But we're at the end here for this calculation. Okay, I got 6 point. Oh no, I forgot to take the square root. Ooh. I got about 2.6 seconds. Okay, to go 15 meters. And again, I'm going to round 2.61, we'll say. It's like 2.6082 or something, using this value that I'd already rounded. So what are you going to do? And the time would be in seconds. Okay, and that's what I get for time. All right. Again, we could solve it with this formula if we wanted to. Wouldn't have to worry about a square root then. It might be a little nicer. Although I did enjoy this term dropping out, but then this term would drop out too, wouldn't it? Okay, yeah, this one probably would have been a little quicker to solve.